Ladies and gentlemen, welcome to my job shop. My name is Keith and I am your host. Today we're starting a new project, and this is going to be an additive project. We're going to be doing some 3D printing. What are we 3D printing? Well, we want to measure up the area in where the shafts go through, the control shafts. We have the slide controls here for the gears, and they got to transfer from the lever through the box to the shift cog. All right, and they're going to be in oil barrier from inside and outside. The stock seal here was packing, regular packing, as in a gland type fiber that's woven and sometimes has wax, silicone. There's all kinds of grades of packing itself, and each one has a different diameter. And they're wrapped around the shaft or cut and fit around the shaft. And then they have small gland, or this happens to be a threaded gland, but the gland actually holds the shape here around the shaft on the back side, and then this screws in and it has a little taper here, and it squeezes that material in from the housing to the shaft. It increases that tension between the two, and that tension builds up enough to keep that material from coming out. Eventually the packing loosens up a little bit and oil flows on out, and that's where all the oil staining of years and years of use are on the front of Pearl, where the quick change gearbox and stuff is down below here, and that was pretty well oil stained up and all of that. We have two larger ports. We have this individual port here, and then we have two smaller ports where the skinnier rod goes through the fatter rod. So there is a small gland here as well. Let me bring you in on that. All right, the nut, I haven't removed the nut, but I have pulled the packing out of it, and this is a really, really skinny wall. So to be able to, and actually this is the inside handle here, okay, and there's another handle that goes outside with the shaft going through here. But you can see that these packings are really accessible from the outside. And when I get these all cleaned up, I'm going to show you how the handles are connected to the shafts so that you can pull these apart and change out the packing without taking the whole gearbox apart. We'll be getting on to that when we get into assembling this and everything. That's why I want to make an O-ring kit out of printed materials. And now let's talk a little bit about that. I'm really new to the additive world as far as my experience, and but it's not stopping me from investigating, and just like every other part of my job shop, you can't get there until you just jump into it and work it out. I learned that there was flexible materials to print, and when I purchased my Ultimaker 5 Pro package there, I ordered or had them ship me some Ultimaker materials, and I purchased these because I wanted to try this material out. This is a TPU 95A by Ultimaker, and I had an O-ring here that was for the running light on my Porsche, and I designed and created a rubber seal, and the material is flexible. It's a little bit harder than an average O-ring. The original seals are almost a foamy type of material, but I was able to put and make two of these to fit in on my early 85 Porsche, and I've been happy with them. Now that's great, but I want to ensure because I want to print O-rings for this. And what I'm looking for is something that is chemical resistant and can handle some temperatures, just like standard O-rings. So I was talking with Roy down at the Ultimate 3D Printing Store, and he touched bases with KIMYA, the material supplier, and they have a TPU 92A, and this material is chemical resistant, and it's highly popular in food industries, but also in automotive. And it is supposed to handle temperatures up to 160 degrees or so. It prints out and it's formed at two something. And we'll be getting into that more when we get ready to print this up. But this is my material that I am going to measure up these shafts. And I'm going to take this material and we're going to print out some O-ring, and I call them O-ring. They're not going to be round. They're going to be cylindrical, and they're going to have a slight little angle, and they're going to fit in here to represent the void that is normally loaded up with packing. All right, because I would love to have a set of seals that I can put in here, and I can adjust those down, and they're going to hold that material, or the hold the oils and fluids from coming out of the gearbox and coming down all over everything. Also, I'll have everything cleaned up, and I'll be able to pull this apart and inspect and see how these are doing. Okay, through our conversation with our representatives from KIMYA, we decided to go ahead and send me 4 different kinds of materials. Of course, I was really inquiring about the flexible materials, but I have a couple other ones that will be on a shelf for later projects. But right now, this is it. KIMYA's given me the material because they want a real, honest example and test of their materials. And of course, I need a material that's going to work in here. And we're going to give KIMYA the first shot at making a product here that's going to satisfy me as far as pearl and holding out that oil. And so anyhow, let's get on with this video here, because we're gonna first off measure our bores, and we're gonna have to measure the angle of the seal. And we're gonna make a decision: do we want to make them square? I mean, packing comes in there, and packing automatically configures to it. There's this kind of a slope on the back side, and that kind of like helps squeeze the material at that on the inside of the shaft contact. And the gland actually has a taper on it, and that kind of squeezes the backside down. So that's kind of that's how the packing acts. The middle of the void is basically a straight push, but the beginning surface of the packing and the aft surface, or the opposite side, is where it actually makes contact with, squeezes in on the shaft more so than in the center section. So I got to get some shaft dimensions here, and then we got to get them drawn out on our Fusion 360, and then we'll be able to take the file and export it as an STL file. That's what printers read, and then we can put it into Cura, and Cura is how, or the program that controls the Ultimaker 5, which will be printing out that material. Okay, here's the three sizes of seal rings that we're making. And this is our first print doing taper on both sides of the seals. Even the small one is slightly tapered on each side, according to the taper that's on the support rings or gland ring that tightens them in. I'm going to take these now and we're going to check the fit, and then I'm going to show you another close-up. I'm going to cut one of these seals right in half, and then you're going to get a look at the solid center of it and get an idea of how solid I'm making these seal rings. And they are flexible. Alright, so let me install these in, and we're going to make sure that they're going to be the right size dimensionally for our project. I've already put the little one in the shaft here, and I've tightened it down, and I can still rotate this down, or around I should say. Now this one here fits in on the 7/8 shaft. Whoop. let me put the big one down, and we're gonna. Okay, we we chamfered the end, both sides of this. One was cut off and one was a hammered in. All right, and this even slides on easier. And you know, we're looking forward to it being stout like that. All right, and it goes in there like that. And actually, it is really there. You go. You can see that fit right in there. Okay. I got a little bit of that masking tape on here, so I'm gonna have to get a little punch here. Okay, you saw that slide in there, so it's not going in and out, and it's got a firm, and this is past or right at that surface. That's what I want. Okay, now let's take this one. Okay, we're just gonna do the same thing. Slide it over. Slide it over the shaft. Stick the shaft in there. When we have a wrench on this, we'll be able to really tighten that in, and we'll put blue Loctite around the outside edge so that we'll be able to tighten that. And that is close enough to the surface. So all three of our seals, my dimensions are good. And I'm happy with how they're going to fit in there. All right. Now we want to cover another aspect of, are these seals going to do the job for us? We need to prove to ourselves that they're chemically they can reject the chemicals. We know what we're going to fill this up with, but I have four other liquids that I want to go ahead and test this O-ring material with. So let's change up. I'm going to set up my little chemistry lab up here on top of the gearbox. All right, here's one of our samples. This is one of our earlier ones. We left it flat on this side here, and we were trying to just get a good print going, and we wanted to check our angle and that kind of things on our samples. So what I'm going to do is I'm just going to cut down through this with a straight blade, and this is King Starboard down, or not, AZAC. I use King Starboard as well, but that's AZAC trim board. Kind of keep it around, it comes in handy. There is no list played before, so if you tell me more specific, like play music, I can help you. No, thank you. Okay, that gives you a good view of the solid cutaway of my seals. Now let's back up a little bit here. All right, I think that'll be far enough. And I'm going to put out some liquids here. This is water. This is diesel fuel. This is acetone. This is brake fluid. And then this is the hydraulic fluid that I'm going to run in the gearbox. It's my choice. I run it in the closet. I have ever since 1994. And it's done it very well. And this gearbox is going to be that much sweeter inside, and I'm going to think nothing less of not using the same. I'm going to use the same oil. All right, so we're going to open up and we're going to put a sample of our material in these containers. Now we're not going to see any results right away, probably. It'll probably take a duration of time, and hopefully we're not going to see any reaction to any of these fluids here. And this is kind of my own test. You know, I purchased the scanner from Ultimate 3D Printing Store, and they put me in touch with KIMYA. That's what I'm getting the material for, because I requested a material that I can manufacture seals with. And so they've given me the material, and I'm not really doing a review on their material. I am just going through the process of sharing my new ventures and how I'm going about it. And I want to know, I'm proving this material to myself, not just to you. I'm sharing myself proving with you. All right, so this is the water, and we're going to drop a piece in there. This is the diesel fuel. We're going to drop a piece in there. Now, if we notice anything eventually making the material soft or breaking apart or anything like that, we'll know that the material is not going to be compatible with that material. But if it starts just acting a little bit funny, then hopefully everything stays stout and doesn't break apart. The big test might be this acetone. Acetone pretty well eats a lot of plastics, and we'll just see. All right. I chose brake fluid. Brake fluid is just one of those chemicals that's around the shop, and brake fluid will either cut through it like paint or whatever. And we're going to go ahead and we're going to drop one of our whole small O-rings in here in the hydraulic. Number 2 hydraulic fluid is what we like. Now this is our own test, and we're going to be following up with this test because I'm printing off right now. I'm printing off another set. I've had stringy. I don't have any pictures of it, but I have stringy issues with the printing, and I just changed some of my settings in there, and I got a really nice print coming out now. With the TPU materials, with it being so rubbery and stretched, you've got to make a couple changes in your settings. And there's a combing setting in Cura, and it really is night and day. The material was pretty dry when I got it, but I still put it in the oven, and I baked it at 80 Celsius. I think it was like 170. I was keeping it between 170 degrees and 185 degrees, in that realm right there, for 2 hours. And then I put it in the printer, and it gave me the same thing. So my material was dry when it came out of the sealed container. And also too, I have the Ultimaker 5 bundle, and its material storage also helps dry material as well. So my biggest issue with what you see in the testings of these here and the set that I'm running right now is basically that combing setting in Cura. All right, here's a look at the stringiness that you do get with this material. Now this is cut back about 95% running the combing capabilities in the Cura, and I'm pretty pleased that it is minimized to this amount. It'll clean up. I mean, this comes loose. Heat gun gets rid of a lot of it, and the little dikes and little razor blade get that trimmed up. Okay, I just thought I'd give you a good look at the stringiness that you do get with this material, but it doesn't affect the actual shape of the project. Here's the start of our chemicals. I do see a little tiny bit of bubbling around the acetone. I don't see any bubbling there. Bubbles are stuck to the side there. Don't see nothing in there except for purple. And that's pretty well lifeless as well. It'd be curious to see. Alright, might have been just bubbles on the material as I set. It doesn't look like it's fizzing. This is the real deal. Alright, I think we're going to call that for tonight, and not that this will be the end of the video, but for right now, that's what I wanted to kind of show tonight, was the fit up and the chemical test, the start of the chemical test. Time will tell. Time will tell. What we don't want, we don't want seals that are going to fail down the road. All right, it's been almost 48 hours since we put the materials in there. I was going to do this last night, but something came in, and hey, what the heck? A little more time doesn't hurt. So we're just going to grab, I'm going to zoom you in, and I really haven't done anything with them. I haven't shaken them up or anything. I have looked at the one with the acetone because it's the only one that really kind of looks like any shape changing has been going on. But we'll look at that one. We're going to start over here at the water and work our way on over here. All right, let me bring you in so that you get just a close look at this as I do. All right, let's start out with the water here. Let's go ahead. I'm going to just slide these over here. So we have room right here for our container and a little bit of working room. See, I put the little W on the lid. Same with the rest of them. I labeled them all. All right, we take the 1970s tool in here and it worked back and better in the 1970s. Okay. Still pliable. It doesn't look like it shrank. It's holding its own. It's still solid. Looking pretty good. All right, we're gonna put this back in here because we're gonna keep them in these liquids all the way to the day that we install the new seals. All right. Water passes with a good check there. This is diesel fuel. I'm gonna bring a little rag over here. Let's see if I can do this the first time. Yeah, there we go. Still got some of the hairs out here. Still feels the same. Still looks the same. It doesn't seem to be stretched, shrank. It's solid. It's not slimy. I meant to say that about the water one as well. All right. So, so far, it looks like it's handling the diesel fuel as well. So we'll go ahead and we'll take the diesel and put it over by the water. All right. Now here's the one that's really... and acetone eats up almost every bit of plastic, but this is really supposed to be a rubber material, not so much a plastic. So let's see what we got here. Okay. There's a little shredding on the outside. This is like the paper. There was paper on the tape that was holding this to the bottom. It's extremely more pliable now. It has softened up the material. I see a little bit of separation on my layers right here, or just some cracking from it stretching out. Now, this is this ring right here. So you can see how much more of that is expanded. The expansion, I would say it's a good 5/16 of an inch expanded. All right, that's in the acetone. It's going to be curious to see what happens to this by the time we install these seals. Okay, we had a feeling about this, and so far our feeling is pretty good, but there's hardly anything that acetone doesn't break down. All right, this is brake fluid. Everybody goes, hey, where'd you get the purple brake fluid? It's .5 brake fluid, and it happens to come that color. I forget if it's Napa or something like that for the brand. Brake fluid is also another chemical that really kind of eats up everything. Plays hell with paint jobs. And this looks just the same as the stock. It feels firm like it was. It hasn't broke down. It hasn't made it slimy. It hasn't made it separated. It's still looking really, really good. All right. So brake fluid is not affecting this. It's pretty good. This material said that it was chemical resistance, but it didn't list all the chemicals that it does resist. So I'm picking chemicals that are common in my shop here for different things that I use. Now here's the true one, and this is really the only one that matters. And this is the number 2 hydraulic fluid that I will be running in this gearbox. And that's my choice of oil to run in the gearbox. A lot of people want a lot of different things, and I'm not going to argue with them, and I don't expect to be argued with. All right. Now this, I put one of the little rings that and I left it round because I want to compare it dimensionally too, and it doesn't seem that it is changing in dimensions at all. And it's still stout like it was, and flexible still. Looks dynamite. It's still 930 on the outside, and it's about 740 on the inside. You know, we programmed it to be 750 and 15/16 on the outside, so it was slightly, you know, give or take a few thousandths is how we printed that, and it's still the same. So we're happy and content that one, this material is holding up to our hydraulic fluid, and it's holding up to water, diesel fuel. Acetone is breaking down, but brake fluid and hydraulic fluid there. If I think of another fluid that might be questionable, or if you have another suggestion and you want to test it in a chemical, and if I happen to have that chemical around, we'll go ahead and we'll jar up a piece and we'll see how it acts, and throw it in a future video. All right, KIMYA's given this material to test out and use for our project here, and I just wanted to disclose that it was a gift of material, and I told them I would share using it on my video, so it's just a mutual agreement that we were bringing some attention to KIMYA material. And so far, that's the material that's looking and leading to being able to make these seals for me on this gearbox. All right, until the next video, get her done.